Hello everyone, welcome to Clean Coder YouTube channel. If you are new to this channel, I will highly recommend you to subscribe to this channel as I make tutorials related to data structures and algorithms, software engineering and system design. So today we are going to solve this lead code problem number 449, serialize and deserialize binary search tree. So let me go through the problem statement quickly. So it says serialization is converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection link to be reconstructed later in the same or another computer environment. We need to design an algorithm to serialize and deserialize a binary search tree. There is no restriction on how our serialization deserialization algorithm should work. We need to ensure that a binary search tree can be serialized to a string. This string can be deserialized to the original tree structure, and the encoded string should be as compact as possible. These are the examples. Will go in depth on the whiteboard. There are some constraints given. The number of nodes in the tree is in the range 0 to 10 to the power 4, and individual node is between 0 to 10 to the power 4. The value of individual node is between 0 to 10 to the power 4, and the input tree is guaranteed to be a binary search tree. Cool. Let's uh, try to derive an algorithm, like how we can solve this problem. Let's try to brainstorm a bit. We are given a BST and we need to convert it into some string which is called serialization here. Okay, this they are calling serialization, and then we need to bring back the BST again from the string. This they are calling it deserialization. Okay, so what could be the algorithm to do this process? So the algorithm is quite simple. I have written that in the next slide. Let's go through that. So the algorithm is do a pre-order traversal and obtain a string. We'll do a pre-order traversal of BST and we'll get a string. Let's call this serialized string. Okay. So once we get this serialized string, we can use this serialized string to make the BST again. This is the simple two-step algorithm using which we can solve this problem. So let's see an example in the next slide how we'll solve that in the example test case. So this is the example they have given to us in the problem statement. So the pre-order traversal, what is the order of pre-order traversal? Pre-order traversal order is first root is processed, then left is processed, after that right is processed. This is the order followed in pre-order traversal. So if we say this is the root, so first 2 would be processed, then 1 would be processed, and 3 would be processed. So pre-order traversal of this binary tree would be 1, 3. Okay, so this is the process of deserialization, and we'll get this 2, 1, 3 as serialized string. Okay, so what we can do now is we'll pick this string, serialized string, 213, and what we'll do is we'll process this string character by character, and somehow using some algorithm we'll be able to obtain this tree back. Sounds simple, right? But like there are some challenges involved. Let me discuss those challenges in the next slide, which you will face while trying to implement this approach. Okay. So the challenges which you will face. The first challenge is how will you separate two nodes in pre-order traversal? Okay, so let's say this is the binary search tree. Its pre-order traversal is 213, right? There could be another binary search tree like this 2 and 13, and its pre-order traversal is also 213. Now how you will distinguish these two trees? This is the first challenge. And now there is another challenge, which is yeah, same point I have emphasized here. There is another challenge. How will you know which ones were the leaves when you are deserializing the tree, right? So this 213, right? We don't know whether 2, whether 1, whether 3 was at leaves, right? There is no special markation done, so that using which we will be able to identify which were the leaf nodes. So we need to follow certain approach using which we can mitigate these two limitations. So how we can mitigate these two limitations? Let me discuss that on the next slide. So these are the two simple, I'll say, steps using which you can solve those challenges. So you can separate nodes with space. So when you are doing pre-order traversal, let's say the tree is that 213 only, 213 only. So when you print the root, give a space, then write the left node 1, then again give a space, then write the rightmost node 3. So using which you can mitigate the first challenge on the previous slide. But like still, the second challenge still remains. You can't identify the leaf nodes while deserializing. You don't know whether 2 was at the leaf, 1 was at the leaf, or 3 was at the leaf. So what you can do to mitigate this challenge? It's again simple. So when you have this 2, 1, 3, what you do, you assume there are dollar character instead of nulls. Okay, wherever there is null, put a dollar character. Now what you can do, when you will write the pre-order traversal of this tree, you also consider the dollar character in the in that pre-order traversal. So what would be the pre-order traversal now? It would be 2, 1, then it would be dollar, dollar, right? Then it would be 3, dollar, dollar, right? This would be the pre-order traversal of this tree. Now, if there are let's say a tree like this, 2, 1, 3. So what would be its pre-order traversal using the similar approach? So you assume dollar, dollar here, a dollar would be here, right? So the pre-order traversal would be root 2, pre-order traversal would be root 2, left dollar, then right 13, then again left, then again right. This would be the pre-order traversal. And you need to give the spaces also. So after 2 you will give a space, after 13 you will give a space. Okay, so using this approach you can solve this problem statement. Okay, let me go to the next slide. Cool, let's repeat the process for this tree as well. Okay, assuming this is the tree given to us, so what would be the pre-order traversal of this tree? Let's append the dollars at the correct position. Now let's write the pre-order traversal of this tree. It would be it is at the root 10, 10, 5, 1, dollar, dollar. After that it would be 7, dollar, dollar. After that, it would be 20 dollar. So this would be the uh, pre-order traversal of this binary search tree. So now we can deserialize this. Obviously, there are spaces after each node values. So there are these spaces. Okay, so we can easily deserialize this string and we can construct this original binary search tree from this string. How we can do it? Know how we can process this string from left to right, and we know that this would be the root, this would be left, this would be right, and then we can do skipping also, and this process we can repeat recursively and we'll be able to deserialize this above binary search tree. Let's show you the code which I used to implement this. So this is the code snippet. Let me show you the serialization part first. So this is the function given to us to serialize. This is the root of the binary tree given to us. I'm using string builder because the strings in Java are immutable. So if we are manipulating the strings, we should use string builder or string buffer. I'm using string builder. So after that, I'm passing this root and this string to this recursive function, and finally I'm returning the string buffer to string conversion back. So this would return the serialized string. Serialized string. Okay. Now this pre-order traversal is nothing but like it's doing a pre-order traversal of the tree. So this is the root, this is the left recursion, this is the right recursion, and I am doing all the manipulations before the recursive calls. So this is the pre-order traversal. So uh, I'm appending the tree's node value. This needs to be converted to string, so I'm using integer.toString method, and I'm appending a space after that. And when I reach the leaf node, I am appending the dollar for the reasons I have told you earlier. So this is the serialization part. Let's move to the deserialization part now. Okay, so this is the function which is given to us. This is the string parameter which we will receive from the above serialization process. So here are some base conditions, like if string is null, there is no BST, right? I am directly returning null. So if we have a dollar, in that case also we can return a null. So after that I am having a index. This is just for keeping the index, like between different recursive calls we can persist the index, so that something similar to pass by reference in programming languages like C. I am trying to accomplish using this array of size 1. So I am initializing it with 0 and I am passing that to this ct constructory function, this string and this index. So let's move to the recursive calls first. So this tree needs to be constructed, right? So I am taking a new tree node root with the value val. Okay, what is val? Val here is the value obtained from the parsed string. So string and index. I have a method parse string. What it's doing? It's just picking the value from the string and uh, allowing us to add that value to the tree node. So this function is just doing that. Let's say the string as 100, right? So it will pick this 100 value and it will return to us as integer, and we'll put that in value and we'll put that value in the tree node. After that, the process is simple. I have put this value here and I am doing left recursive call, and After that, I'm doing write recursive call, and this process would be repeated recursively. And finally, I'm returning the root of this tree. There are some base conditions also. Let's check those base conditions as well. So if index of 0, this is the index of the string. So if it's greater than the length of the string, or I'm at the dollar indicates leaf nodes, right? So I am incrementing the index by 2 in that case and returning the null. Okay, so for obvious reasons, this is the base condition. So let's check the time and space complexity of this solution. The time complexity of this solution is order of n. Uh, this this parsing method, it's not really computational heavy because the size of the number is not much. It's I think about it's still about transfer 4 only, so we can ignore the complexity of this parse string method as it's not much computationally heavy. So it's so time complexity overall is O of n only, and space complexity is also O of n, as we are using additional string to solve this problem. So that's all I wanted to talk about regarding this problem statement. So if you liked my explanation and if you like my code walkthrough, do give it a thumbs up, and you can share this with your friends, and you can subscribe to this channel, Clean Coder. Once again, thanks a lot for watching this video. Hey guys, do check out this Instagram channel, Clean Coder Community, for all the jokes and memes related to software engineering. Thanks a lot.